This is a picture of the Monongahela Incline in Pittsburgh, Pennsylvania. Basically, it's just a little railroad track that goes up the side of a hill. There's a road that goes up the hill too, but it has a lot of switchbacks and it's narrow and steep and you can't go very fast. So this incline is actually a very efficient way of traveling from the top of the hill to the bottom, or vice versa. We know the length of the railroad track. And we know the vertical rise from the bottom of the hill to the top. What I would like to know is what's the angle of this railway with the horizontal. So I'm going to draw a picture. Got my railroad track that goes up the hill. And the vertical rise, that's vertical. And I want to know the angle that the railway makes with the horizontal. We'll do it in degrees since this is an application. The ground and vertical are at right angles to each other, so this is a right triangle, and I'm looking for an angle in this one. I know 369, and that's the opposite side in my triangle. 635 is the hypotenuse. The trig function that uses the opposite and the hypotenuse would be the sine function. So we're going to say sine of my angle is opposite over hypotenuse. So I'm going to need an inverse sine to find the measure of the angle. And if you start here, that's totally fine. If you don't do that first step, I have no argument with that. And we'll put it in the calculator just like that. Inverse sine of 369 over 635, and we come out with an angle of about 35.5 degrees. Looks like more than that. Looks like more than that. Looks steeper than that when you're in it too, but 35.5 degrees.